The age of Earth. The question of the age of the Earth has fascinated philosophers, theologians, and scientists for centuries, primarily because the answer puts our lives in temporal perspective. Until the 18th century, this question was principally in the hands of theologians, who based their calculations on biblical chronology. Bishop James Ussher, a 17th century Irish cleric, for example, calculated that creation occurred in 4004 BC. There were many other such estimates, but they invariably resulted in an Earth that's only a few thousand years old. By the late 18th century, some naturalists had begun to look closely at the ancient rocks on the Earth. They observed that every rock formation, no matter how ancient, appeared to be formed from still older rocks. Comparing these rocks with the products of present erosion, sedimentation, and earth movements, these early geologists soon concluded that the time required to form and sculpt the present Earth was immeasurably longer than had previously been thought. Their conclusions nicely expressed the tremendous intellectual leap required. From then on, geologic time was finally and forever severed from the artificial limits imposed by the length of the human lifetime. By the mid to late 1800s, geologists, physicists, and chemists were searching for ways to quantify the age of the Earth. In 1862, the physicist William Thomson, who later became Lord Kelvin, published calculations that fixed the age of the Earth at between 20 million and to 400 million years. He assumed that Earth had formed as a completely molten object, and determined the amount of time it would take for the near surface to cool to its present temperature. His calculations were flawed in that they did not account for the heat produced via radioactive decay, a process then still unknown to science, or convection inside the Earth, which allows more heat to escape from the interior to warm rocks near the surface. There were other estimates, but the calculations were hotly disputed because they were all obviously flawed by uncertainties in both the initial assumptions and the data. Geologists had trouble accepting such a short age for Earth. Biologists could accept that Earth might have a finite age, but even several million years seemed much too short to be plausible. Charles Darwin had proposed his theory for the evolution of organisms by natural selection, a process whose combination of random heritable variation and cumulative selection implies great expanses of time. Geneticists subsequently measured the rate of genetic divergence of species to date the last universal ancestor of all living organisms no later than 3.5 to 3.8 billion years ago. It was not until the 1960s, when the technique of radiometric dating was fully developed, that scientists began to reach a somewhat more reasonable calculation about the Earth's age. Radiometric dating is based on the decay of long-lived radioactive isotopes that occur naturally in rocks and minerals. These parent isotopes decay to stable daughter isotopes at rates that can be measured experimentally and are effectively constant over time regardless of physical or chemical conditions. With the help of several radiometric dating methods, the oldest rocks which have been found so far on the Earth date to about 3.8 to 3.9 billion years ago. While these values do not compute an age for the Earth, they do establish the lowest limit.